For a few moments, Flores Island was shaking. Then the shaking stopped. But the disaster didn't end. Across parts of eastern Indonesia, roads were blocked by landslides, communities were cut off, buildings were damaged or destroyed, communications became difficult, and rescue teams were suddenly facing a problem that had nothing to do with distance. The roads themselves were disappearing beneath debris. A powerful magnitude 7.7 earthquake struck off the coast of Florence on August 15, 2026, at around 5:58 in the morning local time. The earthquake was shallow, and the shaking caused widespread damage across parts of East Nusa Tenggara. Authorities reported dozens of deaths, hundreds of injuries, thousands of people evacuated, and extensive damage to homes and public facilities. But one of the biggest problems wasn't simply what the earthquake destroyed, it was what the earthquake set in motion afterward. Landslides came down across mountainous areas, roads were blocked, some communities became extremely difficult to reach, and with aftershocks continuing, rescuers had to work in terrain that could become dangerous again without warning. The earthquake may have lasted only minutes, but on Flores, the ground kept causing problems long after the main shaking stopped. And what made this disaster so dangerous wasn't just the earthquake, it was the chain reaction that followed. Before the earthquake, Flores looked completely different. Roads connected communities across the island, people were starting their day, vehicles were moving between towns, families were going about ordinary routines. The mountains and hills surrounding many communities were simply part of the landscape, beautiful, familiar, and most of the time, easy to ignore. But beneath that landscape is a region shaped by powerful geological forces. Indonesia sits along one of the world's most active earthquake zones. The country is part of the Pacific Ring of Fire, where tectonic plates interact and powerful earthquakes are possible. Flores has experienced major earthquakes before. In fact, the island was devastated by a magnitude 7.7 earthquake in 1992 that generated a deadly tsunami. But decades had passed. For people living their everyday lives in 2026, the danger was mostly something they knew about rather than something they were experiencing at that exact moment. Then, early Saturday morning, that changed. The first shock. At approximately 5:58 a.m. local time on August 15th, the earthquake struck offshore from Florence. The magnitude was 7.7. Its shallow depth meant the shaking could be especially destructive in nearby areas. And because the earthquake happened close to populated parts of East Nusa Tenggara, the effects were felt across a wide region. People woke up to violent shaking. Buildings moved, objects fell, structures were damaged. And within minutes, the normal morning had turned into an emergency. Authorities also issued a tsunami warning after the earthquake. That warning was later lifted, as monitoring showed that the tsunami threat had diminished. Small tsunami waves were nevertheless recorded in some locations. But for many communities, the most immediate danger was already on land, because when the earthquake shook the mountains began responding, and that created a second disaster. When the mountains started moving, here's something important about earthquakes. The ground doesn't have to split open beneath a building for an earthquake to be destructive. In mountainous regions, the shaking can destabilize the land itself. Imagine a steep hillside. For years, gravity is constantly pulling soil and rock downhill. Normally, the slope holds together, then a powerful earthquake suddenly shakes everything sideways. Cracks can develop, loose material can shift, rock can break away, and entire sections of unstable ground can move downhill. That's a landslide. And after a major earthquake, landslides can become one of the biggest secondary hazards. That's exactly what happened across parts of Florence. Reports describe landslides blocking roads and complicating access to some of the hardest hit areas. The Trans-Florence Highway was among the routes affected, and this created a problem that is easy to underestimate. Imagine you're a rescue team. You know there may be people who need help several kilometers away. You have vehicles, you have personnel, you have supplies. But then you reach the road, and the road is gone. Not damaged, not simply slowed down, blocked by earth, rock, and debris. Suddenly, the distance on the map doesn't matter anymore. The problem is getting through. And that's when an earthquake becomes something much bigger than shaking. The second disaster. The earthquake itself was the first event. The landslides were the second. And together they created a chain reaction. Earthquake. Then, severe ground shaking. Then, unstable slopes collapse. Then, roads become blocked. Then, communities become isolated. And finally, rescue becomes slower and more difficult. That last part is critical. In a disaster, time matters. Emergency workers need to reach damaged areas, medical teams need access, supplies need to move, information needs to travel, but all of those things depend on infrastructure. Roads, bridges, electricity, communications. And when several of those systems are damaged at the same time, the disaster becomes harder to understand and harder to respond to. That is what rescuers faced in Florence. The problem wasn't simply finding out where the damage was, it was reaching some of those places. The communities cut off. Reports from the affected region described extensive damage across several areas of East Nusa Tenggara, Manggarai, East Manggarai, Nagakeo, Sika. And other communities across the region were dealing with the aftermath. Thousands of people were evacuated. Some residents moved into sports facilities or temporary shelters. Others stayed outdoors because they were afraid another strong earthquake could strike. Power and communications were disrupted in some areas, and roads blocked by landslides made access particularly difficult. At least 1,150 homes were reported damaged or destroyed in the latest assessments, while schools and healthcare facilities were also affected. But numbers alone don't really show what an isolated community looks like. Imagine living in a village surrounded by steep hills. You know, the nearest major town is not extremely far away. Normally, you could get there by road. But now the road is blocked. You can't simply drive around the obstacle. You may have to wait for heavy equipment, or use another route, or in some places, approach by a different method altogether. And while that is happening, the earthquake is still producing aftershocks, which creates another problem, because the landscape may not be finished moving. The view from above. From the ground, a landslide can look like one enormous pile of earth. But from above, the picture can be completely different. Aerial and satellite imagery can reveal scars running across hillsides, roads interrupted at multiple points, sections of vegetation suddenly missing, new paths carved through slopes, and entire areas where the landscape no longer looks the way it did before the earthquake. This is why aerial observation is so important after major earthquakes. Rescue teams on the ground can see what is immediately around them, but satellites can help provide a much wider view. They can help authorities identify areas where landslides may have occurred. They can show which roads may be blocked, and they can help emergency planners understand where access might be most difficult. But even that isn't always enough, because a map can show you where the road is blocked. It doesn't automatically tell you what is happening to the people on the other side. That's why ground teams still have to go in. And in Florence, reaching some areas has been one of the central challenges. Why Flores is so vulnerable? So why did the earthquake create such a difficult situation here? Part of the answer is geography. Flores is mountainous. Steep terrain is naturally more vulnerable to landslides when strong shaking occurs. Then there's the geology. Indonesia sits in a region where tectonic plates are constantly interacting. The earthquake that struck Flores was linked to movement along the region's active fault systems. And because the earthquake was shallow and powerful, the shaking was capable of producing severe ground effects. This is an important distinction. An earthquake doesn't create landslides randomly. The risk depends on several factors. How strong is the shaking? How steep is the terrain? What kind of rock and soil make up the slope? Has the ground already been weakened? Has rainfall saturated the soil? Are there roads or structures cutting into unstable slopes? All of these factors can influence what happens. So, when a major earthquake hits a mountainous island, scientists and emergency planners aren't just thinking about collapsed buildings, they're thinking about the landscape, because the landscape itself can become part of the disaster. And then come the aftershocks. This is where the story becomes even more complicated. The main earthquake is over, but the earth doesn't necessarily become quiet. Aftershocks can continue. And in the Florence earthquake sequence, authorities recorded a very large number of aftershocks. By August 16th, Indonesian authorities had reported nearly 1,000 aftershocks. That changes the situation for everyone. For residents, it means fear of another strong jolt. For rescue workers, it means damaged structures may be unstable. And for the landscape, it means slopes weakened by the main earthquake can potentially be shaken again. A hillside that survived the first earthquake may already have cracks. A rock face may have become unstable. A road cut into a mountain may already be damaged. Another strong aftershock can add more stress. That doesn't mean every aftershock will trigger another major landslide. It doesn't mean another catastrophe is guaranteed. But it does mean the hazard hasn't simply disappeared. The earthquake may be over. The emergency isn't. The hidden danger. Here's the part that is easy to miss. A landslide doesn't always happen at the exact moment of the earthquake. Some slopes can remain unstable afterward. Imagine a hillside with cracks running through it. The earthquake has weakened the slope, but gravity is still working. Water may enter those cracks. Another aftershock may shake the area. The slope can gradually become less stable, and eventually, material can move. This is why emergency teams have to pay attention to more than just the initial damage. They watch for new cracks, fresh movement, unstable slopes, blocked drainage, changes in roads, and weather conditions that could make unstable ground even more vulnerable. The danger becomes a moving target, and that's why the days after a major earthquake can be just as important as the first few hours. What rescuers are watching? So what happens now? Rescue teams have to work on several problems at once. First, they need to locate people who may still require assistance. Then they have to determine which roads are usable. They need to clear debris. They need to inspect damaged structures. They need to restore communications. and they need to keep emergency workers safe while doing all of this. Thousands of military and police personnel have been deployed to assist the response, with operations focused on areas where access remains especially difficult. But there is another challenge. Every new piece of information can change the plan. A road that appears open may become blocked again. An aftershock may force rescuers away from a damaged structure. A landslide may reveal that a slope is less stable than expected. Weather can change conditions, and communications can fail. So, disaster response isn't one giant operation moving in a straight line. It's constant reassessment. Observe, decide, move, reassess, and repeat. The bigger picture. Now take a step back. At first, the story looks simple. A magnitude 7.7 earthquake struck near Florence, but look at everything that followed. The earthquake produced powerful shaking. The shaking damaged buildings. The shaking destabilized mountain slopes. The slopes produced landslides. The landslides blocked roads. Land roads isolated communities. Isolation complicated rescue. Aftershocks created additional uncertainty. And damaged infrastructure made communication and movement harder. One event, multiple consequences. That's the deeper story. The earthquake wasn't just a single moment. It was the beginning of a chain reaction. And this is something scientists have seen in major earthquakes around the world. The ground shaking may last for seconds or minutes, but the effects can continue for days, months, or even longer. Roads have to be rebuilt, slopes have to stabilize, buildings have to be inspected, communities have to recover, and the psychological impact can last long after the physical shaking ends. The question of the tsunami. There was also another threat after the earthquake. A tsunami warning was issued for parts of the region. That warning was later lifted. Small tsunami waves were nevertheless observed, with reports of a wave reaching about 1.6 meters in Ryong village. This is another example of how one earthquake can create multiple hazards at once. The same earthquake can produce ground shaking, landslides, structural damage, aftershocks, and, depending on the location and movement of the seafloor, tsunami waves. That's why emergency authorities don't wait for one problem to appear before responding. They have to consider several possible consequences simultaneously. And on an island like Flores, where communities are surrounded by both mountains and ocean, that complexity matters. What scientists are learning. Every major earthquake provides scientists with more information. They study where the strongest shaking occurred. They examine the fault that moved. They map landslides. They compare satellite images from before and after the earthquake. They analyze aftershocks. And they look at how buildings and infrastructure responded. All of that information can eventually help improve future hazard assessments, because the goal isn't simply to understand what happened yesterday. It's to understand what could happen the next time. Indonesia has experienced devastating earthquakes before. The 1992 Flores earthquake, also magnitude 7.7, generated a catastrophic tsunami that killed thousands. The 2026 earthquake did not produce a comparable disaster at sea, but the history is an important reminder of how complex the region's hazards can be. And that's why monitoring and preparedness matter. Not because scientists can predict exactly when the next major earthquake will happen, they can't, but because understanding the hazards can help communities respond faster when one does. The real story behind the landslides. So let's return to the title. A massive 7.7 earthquake struck near Florence, but the earthquake alone doesn't explain the full disaster. The deeper story is what the shaking triggered. The ground moved, mountainsides became unstable, landslides came down, roads disappeared beneath debris, communities became harder to reach, and rescue teams had to work while aftershocks continued. That's why the disaster became so difficult. The earthquake didn't simply damage places, it changed the routes needed to reach those places. And that is a completely different kind of emergency. A damaged building can be inspected, a broken road can sometimes be repaired. But when an entire mountainside moves onto the road, the geography itself becomes the obstacle. That's the hidden danger of earthquakes in mountainous regions, and the landscape can become part of the disaster. What happens next? For the people of Flores, the story now moves into a different phase. The immediate shock is giving way to rescue and recovery. Search teams continue working. Authorities are assessing damage. Roads need to be cleared. Communications need to be restored. People in temporary shelters need assistance, and scientists continue monitoring the earthquake sequence. But one question remains: how much more will the landscape change? Because after a major earthquake, the ground doesn't necessarily return to normal immediately. Slopes may remain unstable, aftershocks can continue, and additional rain could affect already weakened terrain. That doesn't mean another disaster is guaranteed. It means the risk has to be watched, and that's exactly what scientists and emergency teams are doing. The final lesson. The most important thing to understand about Florence isn't simply that a magnitude 7.7 earthquake struck. It's that disasters rarely happen in just one step. One event can trigger another. An earthquake can trigger landslides. Landslides can block roads. Blocked roads can delay rescue. Damaged infrastructure can disrupt communications. Aftershocks can complicate everything again. And suddenly, a few minutes of shaking can create a crisis that lasts much longer. That's why the first images of an earthquake don't always tell the whole story. The buildings that collapsed are only part of it. The roads that disappeared matter too. The slopes that became unstable matter. The communities that became isolated matter. And the hazards that remain after the cameras leave matter. Flores is now dealing with that reality. The earthquake has stopped. But the response continues. And the landscape is still being studied because scientists aren't only asking, how strong was the earthquake? They're asking, what did the earthquake change? What slopes moved? Which roads were lost? Where are the remaining hazards? Which communities need the most help? And what can this event teach us about the next earthquake? Those questions matter because earthquakes cannot be stopped. But the consequences can sometimes be reduced through preparation, monitoring, stronger infrastructure, and faster response. And that's the lesson Flores is giving the world right now. The earthquake may have lasted only minutes, but for the communities beneath those mountains, its consequences can last far longer. The shaking stopped. The ground did not immediately return to normal. And now the question isn't only what happened when Flores shook. It's what happens to the landscape after the shaking is over, because sometimes the most dangerous part of an earthquake isn't the moment the ground moves. It's everything that the movement sets in motion afterward.